All right, we've talked about how the conditional expectation and variance can be treated just as can be viewed as kind of simply as a ordinary expectation and variance, but with respect to the conditional distribution. That's one way to do it when we're fixing a specific value of the conditioning random variable, but another interesting thing that arises is that we can actually treat conditional expectation and variance themselves as random variables because we can treat them as functions of a random variable. So let's see what we mean by that. So we've defined the conditional expectation, and we're going to define now for each x, define a function phi of x as the conditional expectation of y given that x is equal to little x. So we're viewing this now as a function of x. Okay. Then the random variable we can define a random variable phi, this function, evaluated at the random variable x. It's a random variable because it's a function of a random variable. This is the conditional expectation. Sometimes also called the conditional mean, but the conditional expectation of y given x, given capital X. So there's no conditioned value. We're saying this random variable is defined as the conditional expectation of y given x, and this is how we denote the random variable. Okay, so we have a few properties of this, which are, one very important property is that this satisfies what's called the Tower property for conditional expectation, which is that if we consider the expectation of the conditional expectation, we just get back the original expectation. This is the law of cases for expectation. And that's a very, very powerful property that we use all the time when we have conditional expectations, is we decompose the random variable into its conditional distributions. We can easily compute the conditional expectations, and then we calculate the expectation of that, and we get the mean of the original random variable unconditional. The conditional variance is much the same way. So the conditional variance of y given x is defined by variance of y given x equal to psi of x, where psi is defined in the analogous way. This requires that the absolute value, the expectation of the absolute value of y, finite. Okay, so what can we say about this then? So what is an example where we treat conditional expectation variance as a random variable? So again, let's let x and y be jointly normal. Mean 0. Variance 1. covariance rho. Then we already know from before that the conditional distribution of y given a particular value of x is rho x 1 minus rho squared. Conditional expectation of y given x is equal to little x is rho x. Conditional variance of y given x has a specific value is 1 minus rho squared. And then the conditional expectation of y given x then is the transformation rho times the random variable x. Conditional variance of y given x is just the constant random variable 1 minus rho squared. So in this case, we see that, okay, expectation, so this is a random variable. So what is the distribution of that random variable? Well, it has a mean and it has a variance, right? So the expectation of y given x equals rho x has, well, marginally speaking, it has a normal distribution with mean 0 and variance rho squared. What is the variance? Think about the variance of the expectation of y given x plus the expectation of the variance of y given x. Well, the variance of the expectation, we've already calculated, is rho squared. The expectation of the variance, well, the variance is constant, so it's 1 minus rho squared. This equals 1, which equals the variance of y. So that's actually a formula that we can also use to calculate variance of y. It's decomposed as variance of the conditional expectation plus expectation of the conditional variance. So that is called the ANOVA, the analysis of variance formula for computing variance, which is kind of the tower property for variance, the way that we express ordinary variance in terms of conditional mean and conditional variance. And then here we have the ordinary expectation in terms of conditional expectation. Okay, so that's something that is actually often very confusing and it takes some time to get used to is thinking of conditional expectation, conditional variance as themselves random variables. Sometimes it's a relevant thing to consider, and especially as you go into more advanced topics in probability, it's something that comes up a bit more often and is something that we need to keep in mind.